So here's a kinematic equation that I don't like to use that much because it's a little bit harder to understand what each of the terms means. But this, as you'll notice, time is not involved here. So this equation can help you directly solve problems where you are given some of the velocities, accelerations, displacements, but you're not given anything about the time. Now, usually I'm going to ask questions that are where you could use this, but you're going to end up using both of the other equations anyway. But this equation takes on a lot more meaning once we start to learn about energy. So I need to show you where it comes from. So we have the kinematic equation for velocity. And I want to rearrange this to solve it for time. Right? So I'm going to use algebra to solve for time. So I can subtract v naught from both sides. That's going to give me v minus v naught is equal to at. And then I can divide by both sides by a. And so that gives me that t is equal to v minus v naught over a. Okay, and then I also know the definition of average velocity, or equation for average velocity, is the initial velocity plus the final velocity divided by 2. It's the average of those two. Okay, and so if I take that, both of those things that I know, and then I also have the displacement is equal to, the final displacement is equal to the initial displacement plus the average velocity times time. Okay, so now what I do is I take both of these expressions and plug them in there. So I'm going to plug this in here for t, and I'm going to plug this in here for v average. So what does that look like? That's going to give me x is equal to x naught plus v naught plus v over 2 times v minus v naught over a. All right, so now I'm going to do a little bit of algebra here. So I'm going to subtract x naught from both sides. So that's going to give me x minus x naught over here. And then I'm going to multiply this out. So I'm going to have on top v naught plus v times v minus v naught all over 2a. Okay, so now what I'm going to do is multiply both sides by 2a. So I'm going to have 2a times x minus x naught is equal to v naught plus v times v minus v naught. Okay, so now this is a multiplication of two binomials. So whatever terminology you use to learn how to multiply this out, you might have learned FOIL, right? But it just means that I need to multiply each term in this first set of parentheses by each term in this next set of parentheses. And when I do that, that's going to give me, so I'll have v naught v plus v squared minus v naught v, and then minus v naught squared. So this v naught v terms, I've got one that's positive and one that's negative, so they cancel each other out. So that's going to give me 2a times x minus x naught is equal to v squared minus v naught squared. And then finally, I can move the v naught to the other side, v naught squared to the other side. So that's going to give me v squared is equal to v naught squared plus 2a x minus x naught. So that was what I was looking to find. And that's an equation that you can use, although, as I said, it takes a lot of algebra to kind of manipulate it. And yeah, it works as an algebraic expression, but the sort of meaning and understanding of it is a bit more elusive.